Is 2.7 getting down to business. So we have these two companies, Calcurama and ComputerFest. Calcurama had a net income of $5 million in 2010, while a small competing company, ComputerFest, had a net income of $2 million. So because there's two different companies, I'm going to start off by highlighting each company in a different color. So we have Calcurama had a net income of $5 million in 2010, and ComputerFest had a net income of $2 million. The management at Calcurama, my green color, develops a business plan for future growth that projects an increase in net income of $0.5 million a year. While the management of ComputerFest developed a plan at increasing its net income by 15% each year. So it says create a standard mathematical model, so table, graph, and equations for the projected net income over time for both companies. So I'm going to start off with the Calcurama. So it starts with 5 million and increases by 0.5 per year. So because we're adding $500,000 each year, I know this is linear. So this is Calcurama. And I want to write my equation. So I'm going to put this in function notation with the f of n instead of y, or f of x. Let's do x instead of y. So we have Calcurama is going to be our f of x. And the reason I'm doing that is to differentiate between the two equations. So we have an increase of 0.5 million per year and a beginning amount of $5 million. So then we have ComputerFest. And we'll call this G of X. So ComputerFest started with 2 million and is increasing by 15%. So remember, when we use these percentages, they get to keep 100% of their current money plus 15 extra percent, which gives them 115% of their amount each year. Now we have to rewrite that as a decimal, which will be 1.15, and this is the rate of change that we put in our equation. So we're not adding 1.15 because that percentage, it is exponential. So we know they started off with $2 million, and that amount is growing by 15% annually. So now we need a table. So if we plug these into the calculator, or if we just do some mental math, we have our x values, which are the years. And then we have our y values, which is the money, or net income. And the money is in millions. We need to make sure we remember that. They don't have $5, they have $5 million. So in 2010, the very beginning year, so the year 0 in our table is actually year 2010 because that's the year that they're doing this. So in 2010, they had $5 million. And we say it's year 0 because that's when they're starting this projected business plan. So then after 1 year, they add 0.5 million, which now they have 5.5 million. So then in the next year, they do the same thing again. So they add another $500,000. So now they're at $6 million. And then at the end of the next year and the next year, we'll take it to 5 years. So that would be at year 6. Added on to that 6 is another half, which gives us 6.5 million. To get from the third year to the fourth year, we do the same thing, our constant rate of change. We have 7 million and then 7.5 million. So at this point, we have looked at years 2010 This would be 2011, 2012, 2013, 2014, and after 5 years have passed on this business plan, it would put them at year 2015. So if we do the same thing with ComputerFest, this one, we have a little bit different of a table. We know that we're talking about years, and we're still finding out the amount of money in millions. So in year 2010, they began this adventure. So that's your zero amount, which is at year 2. I think it's at $2 million. So at year 1, they have 2 million and an additional 15%. So I taught you guys how to use the table function in your calculator. That's going to be one of the ways that you can do this. Or if you don't have the yellow calculator with the table feature at home, we know that our multiplier is that 1.15 because it's at the base of our exponent. So you can do 2 times 1.15 and you get 2.3. So again, we're multiplying it by our multiplier of 1.15. So then we can do it again to find out at the end of the second year how much money they have now, which would give them $2.645. And you can just continue multiplying by 1.5 until you get several values in your table. I'm going to go all the way up to 5, just like we did with Calcurama. And that's what our table will look like. So now we have to put both of these on the graph. So the first thing I notice is that ComputerFest just really isn't bringing in that much money in compared to Calcurama. Is that always going to be the case? And that's what we're going to use our graph to find out. So the first thing you want to do is label your graph. So we know the y values, the x values are years, and the y values is the amount of money in millions. And then you have to put your scale on it. So once you have your scale done on your graph, I'm going by ones in both directions, we can go ahead and plot what we know. So we have, in green, I have Calcurama, year 0. They had $5 million. So we're going to go to 0 on the X, 5 on the Y, and put our dot. And then it increases at $500,000 a year. So get a bigger dot. There we go. So 0, 5 and a half, 6 and a half, 7 and a half, 8 and a half. And because it's linear, we can continue the same exact path all the way up our graph because the slope is a constant rate of change. So then we have ComputerFest, and we've got in year 0, they had 2. And then in year 1, they had 2.3, so a little bit above the 2. In year 2, they had 2.6, a little above half. Year 3 was slightly over 3, and then about 3.5, and then about 4. And if we continue on that path, we end up with 4.6, 5.3, 6.11, 7.03, 8.09, 9.3, 10.7, 12.3, and then 14.15. So what you can notice about both of these graphs is that one of them has a curve, it's exponential, and the other one is linear. So we've got Calcurama and Computafest represented on our graph. And if I were you guys, I would label them with words because maybe you're not using the same colors as me. So this is Computafest, and this is Calcurama. So now that we have those two, we can compare these two graphs. So the first question is asking how they're similar, how they're different. What relationships are highlighted in each representation? So I'm going to let you guys compare and contrast and then use the answer key once it's posted to make sure that you covered all your bases. I've thrown several hints out throughout the lesson so far about which one's exponential and which one's linear and so forth and so on. So then if we look at number 2 on the back, it says, if both companies were able to meet their net income growth goals, which company would you choose to invest in and why? I can't answer that for you because it's asking your opinion. Which one would you choose and why? So you guys also need to do that one on your own. And it says, when, if ever, would your projections suggest that the two companies have the same net income? So if we're looking at when they have the same, we're coming back to our graph and we're answering, when are they equal? Well, that's going to be somewhere in this area right here because that's where they intersect. So this is answering the question when. You always go down to your x-axis, and it's between 12 and 13 years. So when you go to the back and we go back down to that question, it would be between 12 and 13 years after 2010. The lines intersect. And then will they ever have the same net income again? Because one of them is linear and the other one is exponential, that is the one and only place they will ever intersect. The linear is never going to catch up with the exponential again. So no. They will never intersect again. So then the next one says, since we are creating models for these companies, can we choose to have a discrete model or a continuous model? Now, I connected my lines on the front to show you guys where they connect or where they meet. But this is a little bit of a situation. Now, most companies don't measure their profit or their net income until the end. So that would make it a discrete model. So when we're trying to answer this question, there we go. So if it is discrete, the advantages of it being discrete would be that you can see how much money the companies have at the end of each year. And then if you're trying to take a perspective from the long view, like, oh, I'm going to leave my money in this company for 14 years, where would it be at that point? You could easily see that. Now, a disadvantage, this is a disadvantage you wouldn't be able to predict when the lines intersect or how much money the company would have in the middle of the year. So at any given point. So That's our discrete information. Now, if we were talking about, and I'm going to try to make my font a little bit smaller. If we were talking about continuous, an advantage, you could predict values at any given time. So their net income, you could look at 2.5 years and see where that company stands at 2.5 years as far as its income. Disadvantage, you're assuming that the price is, or their amount they're saving, their net income is always increasing. So a disadvantage would be that it doesn't take into account the periods of the year where they may have a little bit of rise and fall. Where their money fluctuates. It may go up, it may go down, but at the end of the year, as long as they're following that same path, it's an easy way to predict it. So with discrete, you're comparing the money at the end of each year when they're actually checking to see how they're doing. With continuous, you would be seeing the amount of money at all time, which may not be accurate because maybe you have a bad month, maybe you have a really, really good month that in the end averages out to that rate of change. All right, so looking at the back, there's 3 types of linear equations. We have y equals mx plus b, which is the slope-intercept form. We have y minus y1 equals m times x minus x1, or the way they've written point slope form right here, where m is the slope and x1, y1 are the coordinates of the points on the line. And then we have the recursive formula, which is f of n, so a function where n is our variable, equals f of n minus 1 plus d. So this is just like the recursive formula we wrote back in our sequences unit. So this would be like saying, a sub 0 equals 1 and a sub n equals a sub n minus 1 plus half. So it means the exact same thing as what we've already done. We're just looking at different variables this time through. Because when you have that a sub n, it is specific to sequences. When you have f of n, a function where n is your variable, then it can be for any kind of situation. Exponential functions. We have the explicit form, which is y equals 10 times 3 to the x, y equals a times b to the x, where b is your multiplier. And a is your initial value, which they already have written down here. And then they have another recursive formula, which is the same as what we used for geometric sequences. So now it says, knowing many different forms and how to use them is like having a toolbox. You can select the tool you need for the job, or in this case, the formula that you want to use to help you solve the problem. For each of the following problems, list out the information. A, the function is linear or exponential. B, does the problem give you a point, a slope, a ratio, and a y-intercept? And C, is the function discrete or continuous? Lastly, D, the domain. So in his job selling vacuum, Joe makes $500 each month plus 20 for each vacuum he sells. So part A, linear or exponential. Our hint is that word plus. So A is going to let us know that this is linear. And then B says, does the problem give you a point, a slope, a ratio, or a y-intercept? So on this one, we're actually given the y-intercept, which is 500, and the slope, which is that $20 per vacuum. So part C says, is it continuous or discrete? Because he's getting $20 per vacuum, you can't sell half of a vacuum. You can't sell 0.482 of a vacuum. So because those counting numbers work, discrete is countable. So this is discrete because you have one vacuum, two vacuums, three vacuums, four vacuums. So D, our domain, is the number of vacuums. And discrete's always done in the funky brackets, and you've got one. We can do 0, sorry. So we can do 0, 1, 2, 3, 4, etc. So then it says, write the equation of a line with a slope of 1 that goes through the point -2, 5. So question A says, is it linear or exponential? If it has a slope, it's linear. So that part B, what does it give you? It tells us the slope is -1 and the point is -2, 5. Part C says, is it linear or discrete? Is it discrete or continuous? So because there's no context, like whatever we're losing one of, this is continuous. There's no words to tell us the limitations. Therefore, this is continuous. And then D, your domain. Because it's continuous, there's no context. Our domain would be -infinity to +infinity because it's just going to be a line on a graph. So then it says, write the equation of a geometric. So that already gives us our hint for A. Geometric is the same as exponential. Sequence with a constant ratio of 5 and a first term of -3. So what does it give us? The ratio, our multiplier, is 5, and the first term is -3. So part C, because this is a sequence, you have a first term, a second term, a third term, a fourth term, a fifth term. There is no half term. That makes this discrete. And your domain would be the term numbers. And in this case, it would be 1, 2, 3, 4, etc. And on to the last page of this lesson. The population of a resort town of Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. Write the equation that models the number of people in Java Hot Springs with T equals the number of years from 2003. So first thing we know, it's increasing by a percent. That makes it exponential. So what does it give us? It gives us the initial population, which was 35,000. So y-intercept is 35,000. And it gives us the multiplier. So the ratio. Remember, 100% of the population stays plus an additional 2%, 2.4%. So we have 102.4%, which is equal to 1.024 as your multiplier. So again, 100% of the people are staying there plus an additional 2.4 each year. So then, is it continuous or discrete? This one is shaky. So I would honestly call it continuous because the people are increasing throughout the year. But others may argue that it's discrete because you can't have half of a person. But discrete would also imply that this 2.4 extra percent is arriving all at once. So I'm going to call this one continuous because you never know when people are going to move there. And D, the domain, would be the time in years. And that would take you from 2003 forward. So 2003 would be your 0 year onward. So your 0 until infinity. Because you can touch 0, 0 as a value in this situation. You use the hard bracket. You cannot reach infinity, so it's a parentheses. All right, on to the next one. It says, write the equation of the function graphed below. So the two things you need to have for this is linear. So A, it's linear because it's a straight line. B, we know our y-intercept. It's right here at -3. We can also figure out our slope in the process. It's right there. So we've got up 3, right 4. So since it's up and to the right, we know our slope is a positive 3/4. Our y-intercept is at -3. So we also know that these points that make up this line are connected. So this is continuous. And the domain is all real numbers. So -infinity to +infinity. All right, so we're on to a new section. So this time we are actually graphing these lines. So the first two, I believe you can do, especially if you create a table. So I'm going to let you guys do those. So create a table of values, list your values from -2. So make your x values -2, -1, 0, 1, 2. And let's go ahead and throw a 3 in there if you need a table to help you do them. These last two are a little bit different. So this one, our first term, so this means right here, this means that our ordered pair is 1, -5. The second half of it is a recursive formula. So it says our common difference is that we're adding 1. So our second term would be 1 more than -5, which is -4. Our third term, we would add 1 again, get -3. Our fourth term, add 1 again, get -2. And those would be the ordered pairs that make up your line. So we have 1, -5, 2, -4, 3, -3, 2, -2, 1, -1, 5, -1 would be the next one. 4, -2, 5, -1. And then, because it's written in function notation, not sequence notation, we could connect those dots to make our line. And there we are. So the last one. We know our y-intercept is 32. So that's our 0 amount is at 32. And then our multiplier is half. So each time we're cutting this in half. So half of 32 is 16. Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. And half of 2 is 1. And then you can keep going from there if you'd like and connect those dots because there is no context. And you will have a decreasing function, a decreasing exponential function. And that's just an eyeball, guys. I can't read the numbers on here. And because I'm on this touch screen, if I start trying to count them, it's going to be very difficult for me to figure out where 32 is. So graph it, check your answers. Let me know if you guys have any questions.